Hello students, welcome to the class once again. Last class we talked about motion in two-dimensional and I told you about how to find the velocity, how to find the acceleration, how to find the direction when the particle was not moving in a straight line, rather it was moving in a plane, that is its x coordinate and y coordinate was changing with time. In today's class we'll discuss about a special kind of two-dimensional motion, that is a projectile motion. I have already given you a description of a projectile motion. Let us say I have a chalk holder in my hand and now I am going to project it at some angle. This reaches me here. Now see, this particular trajectory is known as the trajectory of a projectile and it will follow a parabolic path. See how it would look like. Suppose, let us say the horizontal displacement is given along x-axis and the vertical displacement is given along y-axis. The particle is moving along the two-dimensional space and it is projected in this direction. This is the initial velocity which we have given to the particle. Now it was projected in this way, it will follow a path as given in this figure. Now you can see here this path is actually, it will look like a circular path, semicircular path, but actually it's a parabolic path which will show at the end. Now this was the initial velocity of the particle. Let us say we have projected it at some angle theta with the horizontal. So we can say the initial velocity has got two components as, and let me mark this as, instead of v, to make it to show that it is initial, let us mark this as u. So this will be u cos theta and this will be the initial velocity along the vertical direction will be u sin theta. So we can make out the initial velocity u cos theta along the x direction and it is u sin theta along the y direction. Now the particle is moving along this path. Now this point is the maximum height point. This is the point of maximum height point or the highest point we can talk about. Now when it reaches to the ground once again, when it has reached to the ground once again, this will be the maximum horizontal displacement, or we can say this is the range of the particle. This is the range of the particle that the overall during its course of journey, this will be the maximum horizontal displacement. We can write this as maximum height h. Now at any instant of time, let us say the particle is here. Let us mark the particle is here. Now you see the velocity is changing regularly. Let us say this is the velocity of the particle at some instant of time such that it makes an angle alpha with the horizontal. So we will have two components of velocity, one along horizontal direction. This component will be v cos alpha and this component will be v sin alpha. We got this, we got the velocities varying. Now you see here the acceleration acting on this particle. Now see, the only acceleration acting on the particle will be g, that is acting downward. So I am marking the acceleration acting on the particle, that is acceleration due to gravity, and it is only acting along the vertical downward direction. So all the things are clear to us. Initial velocity is u cos theta along x direction, it's u sin theta along y direction, and the acceleration acting along the only acceleration acting in this motion is acceleration due to gravity, and that is vertically downward. Now to study this motion, to study the projectile motion, we will break its motion along two dimensions, that is one along x-axis and one along y-axis. It will be very simple as to find out the variables that will be required for us. So what I am going to do, we are going to study the motion one along x-axis under x-axis heading and the other along the y-axis heading. Now you see, the initial velocity along the x direction was given as ux and this will be equal to u cos theta as per the given variables. Remember, theta is the angle with the horizontal with which the body was projected, and the initial velocity along the vertical direction is u sin theta. Now the only acceleration acting was acceleration due to gravity, and that was in the vertical downward direction. So I am writing acceleration along y direction as minus g, because I am writing minus g because it's acting downward. So we are taking downward direction as negative, and here acceleration along x-axis, there is no acceleration, so 0. Now what things we can find out from this given figure? You can see that we can find out the range of the particle, that is the maximum horizontal displacement. We can find out the maximum height, during its motion. Now third thing, we can also find out the time of flight, in how much time will it would have moved to complete the total range of its motion. So first thing, when it reaches the ground once again, you see here, it started from here, this was its trajectory and it reached here. When it hit the ground again, its vertical displacement is 0. So let us say capital T is the time taken to reach the ground again, and during its time its vertical displacement became 0. So as it hits ground again, y will be equal to 0. Why I am mentioning that is as vertical displacement, that will be 0. So use s equal to ut plus half at square, you can use this as s equal to ut plus half at square s along y direction will come out to be 0. You know the value of initial velocity, you know the value of acceleration that is acting. So with this we can find out the value of time that it will take to reach finally the ground. Let us try to see that. S will be given as 0, that keep it as 0. Now u value is u sine theta, because we are performing all these equations, we are calculating along the y direction, so keep it as u sine theta into t, and a value is minus g, so I am putting this as minus half gt square. You can see here t will be cancelled out, so either t will be 0 or t will come out to be 2u sine theta by z. So t will come out to be 2u sine theta by g, or we can write in more standard form. Let us say capital T is the time of flight, so I am mentioning this as capital T, that is the time of flight. The first thing we got, t is equal to 2u sine theta by g. Now all the results that I will be obtaining with my subsequent calculations, I will be mentioning here in this right hand portion. So first thing that we got, that is t equals to 2u sine theta by g. Let's keep it separately at this part of the board. Now second thing what we can evaluate, now you see here, again in the figure you see here, at this point the particle is at its highest point. At this point the vertical component of velocity is 0. So see what we can do at this point, and you see here more, here the body along the horizontal direction, it has got no acceleration. So we can find out what's the range of particle if we use u cos theta and multiply it with the total time taken. So now the second thing that we can find out as it hits the ground, so let's write here, as it hits the ground, the horizontal distance traveled, let us mark this with x, this will be equal to ux multiplied by time t. Ux is u cos theta, and since there is no acceleration, so we can directly find out speed into time, and time was 2u sine theta by g. See what will come out, u into u square, and 2 sine theta cos theta. If you remember, 2 sine theta cos theta can be written as sine 2 theta. This will be u square sine 2 theta by g. This is the value of range, so I am mentioning capital X as equal to u square sine 2 theta by g. So again we got a second result, that is for range. So again we are going to use the right hand part of the board, and let us write this result separately, that is range is equal to u square sine 2 theta by g. One more result that we got. Now the third thing, again let's come to the figure. Third thing is here, that's the maximum height. Now as I told you, at the point of maximum height, we can see here the body will have no vertical velocity, because vertical velocity was responsible to move it in the vertical direction, but since here the body is changing its direction, it is not able to move in the vertical direction. The only velocity it will be having at this point will be horizontal velocity, and that will be equal to u cos theta. That is the only velocity that is going to have, that it will be possessing. So let's say when Vy equals to 0, what is the displacement? So I'm rubbing this part. So at the position of maximum height, at maximum height position, or you can say at highest point, at maximum height position, we can write Vy is equal to 0. Vy equals to 0. Now you know that use V square is equal to U square minus 2as, using V square is equal to U square minus 2as, or let's say in standard form plus 2as, and let's substitute the values. Vy whole square is equal to Uy whole square and minus 2gh. H I am using for maximum height. See, Vy will be 0, Uy will be U sin theta whole square minus 2g capital H. Now you see here, just evaluate the value of capital H. You will be obtaining capital H will come out to be U square sin square theta by 2g. This is the value of maximum height that we have obtained. So let's write this result also in this part of the board. Third is maximum height with capital H max, that came out to be U square sin square theta by 2g. You can check it, U square sin square theta by 2g, that is the value of maximum height that we have obtained. Let us have a quick revision of the three formulas that we have derived. T equals to 2u sin theta by g. Second range, R equals to U square sin 2 theta by g. Third, H max equal to U square sin square theta by 2g. In all these three equations, I will request you all, do remember, try to by heart all these three basic equations by any means. Now see, if you suppose you forget, what to do? You have to at least remember one, and I will advise you remember the time of flight formula. Time of flight formula, that is 2u sin theta by g. Simply multiply this with u cos theta, that is the horizontal velocity, you will get range. And now use the direction along the vertical direction, the formula v square is equal to u square minus 2as, and you will get the formula for h max. If you remember this, you can easily evaluate this, or by any means try to by heart all these three formulae. That will be very useful. Now let's come to, again in the derivation part, if you see the formula for range, the range formula says that x equal to u square sin 2 theta by g. Some of the special points that you can note down here for range. Now see, if we keep the value of theta as theta 1 and theta 2 such that, first let me write here one special case. We are talking about range, and range is given as capital X, and that is equal to u square sin 2 theta by g. Suppose you are projecting the particle at angle theta, you will get this range. Now see, suppose you are going to project at some other angle, that is, let's say theta 1, and theta 1 is equal to 90 minus theta. So for theta, we got range is equal to, for theta, range come out to be this, and let's say for theta 1 such that theta 1 is equal to 90 minus theta. Let us substitute this for theta 1 such that theta is equal to 91 minus theta. See what we are going to obtain. X will be equal to u square sin 2 90 minus theta. Not a problem. Or to have more better understanding, let's write this as sin 2 theta 1 upon g. This will come out to be u square sin 2 into 90 minus theta. Not a problem. Just now I told you we are keeping a constraint, we are limiting its value to 90 minus theta. That is, both the angle theta and theta 1 are complementary to each other. So this comes out to be u square sin 2 into 90 will be 180, 180 minus 2 theta sin 180 minus 2 theta upon g. Now see, we know that sin 180 minus any angle will give you the sine of same angle. That is, we obtain this as u square sine 2 theta by g. What implications we can make from here? We can say that for two angles of projection, if both the angles are complementary such that their sum equals 90 degree, the range will be same in both the cases. That is what we mean to say here. If I draw a diagram representing the case that we are talking about, if both the angles are complementary to each other, if theta plus theta 1 is equal to 90 degree, what it implies, that is, if you throw a body at angle theta and another body at angle theta 1, let's say this is 30, another body you are going to throw at 60 degree, let us say this is the angle theta 1. Remember one more thing, velocity should be same in both the case. Okay, the body will be having the same range. So that is what we are interested to know. Okay, so we got one thing. So if both the angles of projection are complementary to each other, then the range will same. So we can make one more point. Fourth point, range is same for two angles of projection if both are complementary and initial velocity is same. For two angles of projection, if theta plus theta 1 is equal to 90 degree, and remember initial velocity should be same. U is same in both the case. Hope this is visible to you all. Now let me talk about, after covering all this basic detail, okay, we have talked about projectile motion. Now one more thing that we can evaluate. As I told you in the case of projectile, we can also find out the equation of trajectory of the projectile. Let's come and find out the equation of trajectory. If you remember in the last class, I told you in the equation you have to find out the relation between x and y. So let's try to find out the relation between x and y. See here, the velocity along x direction is given as u cos theta, so x will be given as, I'll mention this small x kept because we have already used capital X for range. So small x, the displacement along x axis in some time t, displacement along x axis, this will come out to be x is equal to u cos theta into t, okay, and displacement along y axis. Hope you are simultaneously noting down and you are understanding also displacement along y axis. You must be knowing that since we have also an acceleration along the y axis, so we have to very wisely use the equation. Let us use s equal to ut plus half at square. Displacement we are taking positive direction along the upward direction. So s we are using y, u is u sine theta into t minus half gt square, since acceleration is acting downward, y u sine theta. Instead of t, put t as x upon u cos theta. That regularly I have told you, eliminate t and substitute its value, minus half g x upon u cos theta whole square. Write the result. You see, your sin theta by cos theta will give you tan theta, u will be cancelled out, this will be x tan theta, minus, again you see, minus half g x square by u square cos square theta. So you will be writing x square upon 2g and u square, sorry, g will be in the numerator, minus gx square upon 2 u square cos square theta. This is actually the trajectory of the particle, how y and x are related to each other. So note down this equation also separately. Now I am also writing the equation of trajectory. You should remember y equals to x tan theta minus half gx square upon u square cos square theta. This is the equation of trajectory of the particle. Okay, so this was all the basics of the projectile motion, and we have also derived all the 4 things related to projectile: maximum height, range, time of flight, and we also found out the equation for trajectory of the particle. Now suppose one more thing, let me tell you, the time taken to reach the highest point will be nothing, it will be just half of the time of flight. If you want, we can show even that also. Let's prove this. What is the time taken to reach the maximum point, that is the highest point or maximum height point? So let's go and find out the time taken to reach the maximum height. Now at maximum height, what is happening? The vertical velocity is getting 0. Let's put vertical velocity as 0. So at highest point we have Vy equals to 0, Vy is equal to 0. So use V equals to u plus at. We know Vy will be written as uy and minus gt. Vy is 0, uy is u cos theta, sorry, u sin theta minus g, and let me keep this as t half, because, or we will write th for maximum height. So th will come out to be, you can check it as, this will be u sin theta by g. What you can obtain, you have seen, we have already seen that total time of flight was given as 2u sin theta by g, and time for maximum height is given as u sin theta by g. Hope you are getting it simultaneously, and hope you are not getting confused yet while writing in your notebook. So time of maximum height will be also written as time of flight divided by 2. This is the value of time to reach maximum height. If you forget, just remember that it is half of maximum height. Let's continue further and let's do a question on projectile motion. And here the question is, the first question is very simple. A particle is projected at an angle theta with an initial speed u from the horizontal, making an angle theta with the horizontal, and it's projected. Okay, now it has been asked, while it reaches at its highest point, find the change in momentum of particle. So it's a simple projectile